Okay, so this is the second video of today. So August 1st, 2025. Mm, in the previous lecture, we have shown the capability of a deposition, an isotropic one, but it was a little bit difficult to distinguish different layers. So the original one, the bedrock, and added one, and actually there is no difference between them. So they are just considered as empty or filled elements inside our mesh system. So, in this video, I would like to introduce the concept of regions. So, let me just go to the code directly. So, this is the main code to show you the example. Now we have a certain size of our simulation domain. After that, uh, once we start this craft class, when that is initiated, then it only contains bedrock. So why don't we just to go to craft dot uh, cc file. So in this case, we just make the initial mesh, and when we go to the initial mesh generation, then now we make this vector over regions. So, and we add the very first, a fixed one called as a bedrock, and now it is just the previous implementation. But previously, it was directly implemented in mesh.cc or in the class of a mesh. However, instead of that, now these elements are added separately into the very first region. So makes some difference. So when this is over, then this craft only have one single region called as bedrock, and we just save it. After that, we call several deposition routines again and again with names and thickness. For example, first we introduce a substrate region and its thickness is 2, and sacrificial layer thickness 3, channel layer thickness 1, and once again we can call sacrificial again. So yes, now sacrificial layers are called twice. So when we have a look at sacrificial layer, actually they are divided into two pieces, actually of three pieces here. And also same for channel region. Here we have one layer thick channel. After that, separated by this sacrificial layer, we have a second channel and third channel, but they are all recognized as a single name channel. After that, we introduce a capping layer, and that is saved in epi.ggns file. So what we can expect is bedrock.cgns is almost empty cup-like structure, and epi.cgns looks like almost a fully filled cup. So let's just have a look at. Uh, I have prepared an empty directory as usual, um, or clean code as usual. So let me just make a build directory and go to there and type cmake and make. Yes. So now let's just run AngstromCraft. So it's done. And what happens? Now we have two different CGNS files. Of course, one for bedrock and one for epistructure. So let me just first go to this bedrock.cgns. So it is just the same as before, but the reason why I'm showing you this one is now it has one uh, single John. Previously it was named as a John 0, but now it has a different name. And please have a look at this size. Yes, it's okay. So now what happens to epi.cgns? Since we have make a series of depositions, so we expect that is a little bit different from this initial structure. So epi.cgns is shown. Once again, just have a look at it. Oh, now you can easily understand it is almost a field. Also, please have a look at this part. Now, in under this base, we have different zones. And since bedrock is just a container, let's just eliminate it from display. So this is the real structure we will consider in our process emulation. So now you can understand there is a substrate as expected, and other ones like sacrificial channel capping. Well, okay, so although they are not all, so they are just aligned in the appearance order, so you can easily understand the bedrock was the number 0, 1, 2, 3, 4, not alphabetically sorted. And when we go to this one, yes, of course we can display it, but which one is which one? This is a little difficult. So instead of this solid color, let for while let's just use these block colors to distinguish different zones. So when you just click it, then now you can see this structure. Of course, this this color code is not actually corresponding to my own or my laboratory's preferred color code, but I think that for a while it is just okay. And you can easily understand this red one is corresponding to this one, and that is corresponding to substrate, and this green that is corresponding to uh, sacrificial, I guess. After that, this blue one is corresponding to channels, and finally yellow is used for a capping layer. Okay, so now we have the structure for certain CFET structure seemingly. So for this structure, we'll do some etch process and once again deposition, something like that. So let me just go ahead with this code. But I would like to say that this is just for implementation. This the size of this system is quite small. So when we increase the number of cubes inside this system, the implementation becomes very inefficient. So I think that I must spend more time, more effort to make it more efficient. but for demonstration purpose, I guess that this is completely okay. So finally, when I revive this bedrock, yes, now it is covered by this bedrock. Okay, so okay, good. Maybe later we can try to etch down this sacrificial layer, and yes, that will be quite interesting. Thank you for your attention.